Good morning to all. Today we see periodic properties. This unit belongs to first BSc Chemistry in Unit 1, General Chemistry 1. In periodic properties, according to the modern periodic law, the properties of elements are periodic functions of their atomic numbers. This means that when elements are arranged in the increasing order of their atomic numbers, there is periodicity in their properties. Their physical and chemical properties are repeated at regular intervals. This is referred to as periodicity in property. This is the periodic table. In early version of the periodic table were constructed by Mendeleev and Luther Meyer. We know that the periodic properties are due to the electronic structures of atoms. Electronic structures explained observed trends in atomic size, ionization energy, electron affinity. And the electrons in successive shells produce maximum and in the electron density at increasing distance from the nucleus. The inner complete electron shell are called core shells. The outermost electron shells is called as the valency shell. It may include subshells of inner shells. That the example, the valency shell of AS33 includes that 4s, 3d and 4p subshells. First we see atomic volume. What is atomic volume and how it varies from in the periodic table. The atomic volume is defined as the ratio between atomic weight and the specific gravity of the element in solid state. The atomic volume curve contains a series of well-defined loops. Similar elements occupied in the same position. The ascending slopes of these loops contain the electronegative atom and the decreasing slopes contain the electropositive elements. Alkyl metals occupy in the top position in the curve. The atomic volume increases when we go from top to bottom in the group of the periodic table. The number of each period of the periodic table occupy successive position on the curve. The members of each group occupy in the similar position. That is, the alkyl metal groups occupy the top in the curve of the periodic table. What are the factors affecting the atomic volume? First one is the nuclear charge. The nuclear charge, it affects the atomic volume. How? As we move from the left to right in a period, the nuclear charge increases by 1. Thus, increase in the nuclear charge attracts the electron clouds towards the nucleus and decrease the atomic volume. The next one is the number of valency electrons. As the number of valency electron increases, atomic volume also increases to accommodate the electrons. These two factors affect the atomic volume in opposite direction. As a result, along the period, atomic volume decreases, then reaches in minimum and then increase. The third one is the number of energy levels. As the number of energy levels increases, the atomic volume also increases. The second one is atomic radius. Atomic radius is defined as an element is half of the distance between the centers of two atoms of that element that are just touching each other. The radius of an atom may be taken as the distance between the center of the nucleus and outermost shell of the electron. The atomic radius decreases across a period from left to right and increases in a given group. The atoms with the largest atomic radii are located in group 1 and at the bottom of the group. Moving from left to right across the period, electrons are added one at the time to the outermost energy shell. Electrons within the shell cannot shield each other from the attraction of proton. Since the number of proton also increases, the effective nuclear charge increases across a period. This causes the atomic radius to decrease. When moving down a group in a periodic table, the number of electrons and filled electron shell increases, but the number of valency electrons remains the same. The outermost electron in a group are exposed to the same effective nuclear charge, but electrons are found further from the nucleus as the number of filled energy shells increases. Therefore, atomic radii increases. In the atomic radius decreases in a left to right and increases in the top to bottom in the periodic table. Third one is covalent radius. The covalent radius is defined as half the distance between two homonuclear atoms that are in a covalent bond. The distance between the nuclei of any two neighboring atoms is called internuclear distance. For example, the example HCl. The internuclear distance will be equal to the sum of covalent radii of hydrogen and chlorine. The covalent radii of elements decreases from left to right in a period. Thus, in a period of the alkyl metal has the largest covalent radius and the halogen has the smallest covalent radius. This is because the atomic number increases across the period, the nuclear charge increases and the orbital electrons are pulled in towards the nucleus. The covalent radii increases down in a group in the periodic table, that is for the alkyl metals. The covalent radii increases as we go down from lithium to cesium. This is yes because as we go down a group, extra shells are added. Fourth one is van der Waals radius. It is the distance with the half of the distance between the nuclei of two similar non-bonded isolated atoms, or even to adjacent identical atoms belonging to two neighboring molecules of an element which are in a solid state. The weakest force, which are also known as the van der Waals magnitude of the radius, are dependent on the packing of the atoms when the elements in a solid state. The van der Waals radius of chlorine is 1.8 angstrom. It means that the two chlorine atoms belonging to two different chlorine molecules cannot approach each other nearer than 3.6 angstrom from each other without overlapping of their electron clouds to form a bond. For noble gases in a solid state, the crystalline radii, that is atomic radii, are same as their van der Waals radii. Ionic radius. Ionic radius is the distance from the center of the nucleus of the ion to the edge of its electron cloud. In the cation results from the loss of one or more electrons from an atom. This generally causes the removal of the whole of the outer shell of electron. Thus, the formation of cations in the outer shell of electrons is removed completely. Therefore, the cation is much smaller than the corresponding atom. With the elimination of one or more orbital electrons, the effective nuclear charge increases. So, the electrons are pulled in more inwards the nucleus than before. These effects tend to decrease the radius of the cation. So, K plus less than K, that is in the cation less than potassium cation is less than potassium atom. An anion is formed by the addition of one or more electrons to the atom. So, the effective nuclear charge is reduced. So, the electron cloud expands. As a result of this, radius of a negative ion is larger than the corresponding atom. In going from the left to right in a period, there is a pronounced and progressive successive decrease in ionic radii. As we move from top to bottom in a group, there is a progressive increase in ionic radii. In the ionic radius, from left to right is decreases, and also in a group, in a top to bottom, it increases. What are the factors affecting the atomic and ionic radii? First one is effective nuclear charge. In the effective nuclear charge, the magnitude of the effective nuclear charge, to determine the magnitude of force of attraction between the nucleus and the outermost electron cloud. Greater the magnitude of the effective nuclear charge, greater will be the attraction between the nucleus and smaller will be the atomic and ionic radii. The next one is the number of shells or energy levels. As the total number of shells or energy levels that are present increase, the atomic and ionic radius also increases. That is, principal quantum number increases, the atomic and ionic radii also increases. Ionization energy. What is meant by ionization energy? Ionization energy or ionization potential is the energy required to remove an electron from a gaseous atom or ion completely. The closer and more tightly bound an electron is to the nucleus, the most difficult it will be removed, and it is and higher its ionization energy will be. The first ionization energy is the energy required to remove one electron from the parent atom. The second ionization energy is the energy required to remove the second valency electron from the univalent ion to form a divalent ion, and so on. The tri, tetra and penta, so on. Successive ionization energy also increases. The second ionization energy is always greater than first ionization energy. Third ionization energy is always greater than second one. That is in successive. Ionization energy increases moving from left to right across the period and decreasing the atomic radius. In the ionization energy decreases moving down in a group. When a group 1 elements have low ionization energy, because the loss of electron forms a stable octet. Because in a valency shell it has one electron, it loses and it forms as a stable octet. What are the factors affecting? The first one is effective nuclear charge. The magnitude of the effective nuclear charge increases, higher the ionization potential needed to remove the outermost shell electron. So, in a moving from left to right in a period, effective nuclear charge also increases. The ionization potential also increases in a period. In the state of an atom, higher the size of the atom, lower will be the ionization energy. When moved down in a group, the value of size of an atom, the atomic radius increases. So, ionization potential decreases as we move down the group. Because the distance between the nucleus and the electron in the outermost shell increases. So, the force if attraction exceeds by the nucleus on, then will decrease. So, they may be easily removed. Principal quantum number is one of the factors affecting the ionization potential. In the principal, magnitude of the ionization potential decreases with the increase in the value of principal quantum number of the orbit, with the electron is to be removed. The ionization potential of group 2A element decreases in the order. The variation of successive ionization potential of an element is explained on this basis. Lithium electronic configuration is the 1s2 2s1. There is 3 electrons. In the first ionization energy, that the 2s electron is removed. So, the electronic configuration is 1s2. So, the second ionization potential, the 1s electron is removed. Here the magnitude of ionization potential as increases as there is the decrease in the value of principal quantum number of the orbit from which the electron is to be removed. The next effect is the shielding effect. This is one of the factors is mainly influencing for the ionization potential. And the shielding effect is a multi-electron atom. The electrons lying between the nucleus and the valency shell are called intervening electrons. These electrons shield the outermost shell electron from the nucleus. This is called shielding or screening effect. If the shielding effect increases, the ionization potential will decrease. The shielding effect is indicated by sigma, the shielding constant. As we move down the group, the inner shell electron increases. So the magnitude of the shielding effect increases, so ionization potential decreases. The next factor is the half-filled or completely filled electrons. We know that half-filled and completely orbits are more stable than the partially filled orbits. So, ionization potential will be more than the expected normal from its position in the periodic table. So, ionization potential of beryllium greater than barium and nitrogen greater than oxygen. Nature of orbits. In the S, P, D, F are the orbits. What is the nature of the orbit? In the relative order of EC, with the electron occupying these orbitals can be removed, will be as Ns less than Np less than Nd less than Nf. This means that it will be easiest to remove the F electron and the most difficult to remove will the S electron in the given shell. So, in the ionization potential of an electron in the S, P, D, F orbital decreases in the order. Octet arrangement is the one of the factor for the factors affecting in the ionization potential. An atom with octet arrangement, that means Ns2, Np6 arrangement is highly stable. Hence, it is very difficult to remove an electron from this stable octet arrangement. Thus, atoms with a stable octet arrangement have maximum ionization potential. That is examples for inert gases in a periodic table. Electron affinity. Affinity means attraction. That the electron affinity reflects the ability of an atom to accept an electron. It is the energy change that occurs when an electron is added to the gaseous atom. Atoms with a stronger effective nuclear charge have greater electron affinity. Some generalization can be made about the electron affinities of certain groups in the periodic table. In a group, two elements, that is alkaline earth metals, have low electron affinity value. Thus, elements are relatively stable because they have filled F subshell. When group 7A elements, the halogens, have high electron affinity because the addition of an electron to an atom results in completely filled shell. In group 2A, 8 elements or the noble gases have electron affinities near 0. Since each atom possesses a stable octet configuration and will not accept the electron readily. So, elements of the other groups have low electron affinities. In a period, the halogen will have the highest electron affinity while the noble gas will have the lowest electron affinity. Electron affinity decreases moving down a group because a new electron would be further from the nucleus to the large atom. Factors affecting the electron affinity. Atomic radius. In the atomic radius increases, the tendency of the nucleus of an atom to attract additionally electron towards it decreases. So, large atoms have lesser electron affinities than smaller atoms. Next factor, effective nuclear charge. As the effective nuclear charge increases, the tendency of the nucleus of the atom to attract additional electron towards it increases. Thus, atoms with higher nuclear charge have high electron affinities. Electronic configuration. In the completely filled orbital, resists the addition of extra electron. So, that groups for the zero electron affinity. Half filled or stable, and also resist to addition of the extra electron. So, that groups are the low electron affinity value. But halogens have the high electron affinity because its outermost electronic configuration is NS2 NP1. So, these have very high tendency to take up the one electron to attain a stable noble gas configuration. So, halogens for the high electron affinity. The electronegativity. In the electronegativity is a measure of the attraction of the atom for the electrons in a chemical bond. The higher the electronegativity of an atom, the greater its attraction for bonding electron. Electronegativity is related to ionization energy. Electrons with low ionization energy have low electronegativity because their nuclei do not exert a strong attractive force on electrons. Elements with a high ionization energy have high electronegativity due to the strong pull exerted on electron by the nucleus. In a group, the electronegativity decreases as the atomic number increases. As a result of the increased distance between the valency electron and the nucleus. An example, the electropositive element is cesium in the first group, and that's the high electronegative element in the periodic table. What are the factors affecting the electronegativity? First one is the size. Smaller the size of an atom, greater its tendency to attract the bonded pair of electrons towards itself, and hence more will be its electronegativity. In the inner shells, in the more number of inner shells between the nucleus and the outermost shell will have the less electronegativity. So, decreasing order of the electronegativity of the halogens. Oxidation state. In the higher oxidation state have more electronegativity value. This is because that atom in higher oxidation state will be smaller in size, and so we have the greater attraction of electron. So, that the increasing trend of the electronegativities, lithium and lithium ion and iron to Fe2 plus and Fe3 plus ions are given. Number and nature of the other bonded atoms. Electronegativity of an atom is a property which depends on the nature and the number of atoms bound to it. This is the reason why electronegativity value of atom is not a constant. Electronegativity of phosphorus in PCl3 is that in PF3 are different. In the chlorine and the fluorine are both are the halogens in a same periodic table, but electronegativity value is different. Next, ionization potential and electron affinity. Atoms have higher ionization potential and the electron affinity will have the higher electronegativity values also. In halogens or more alkaline metals or the less ionization, that is in electronegativity value. In the types of hybridization, in the sp3, sp2 and sp hybridization, the magnitude of electronegativity increases with the increasing the s character of the hybrid orbital. So, the increasing in the same order sp3, sp2 and sp. Conclusion in the periodic table. In a periodic table, when moving from the left to right in a period, atomic volume increases, atomic radius decreases, ionization potential increases, electron affinity generally increases and the electronegativity increases. When moved from the top to bottom in a group, atomic radius increases, ionization energy decreases, electron affinity is decreases, and electronegativity decreases. I hope all of you let us clear note about the periodic properties in a periodic table. Thank you.